Hi everyone, this is Bipin Kumar, founder of RPM Tutorials. Welcome to my channel. In my last video, I talked about surface area and volumes, particularly about volumes of the common objects. Today, let's utilize those concepts which we learned in last video. Let's look at one problem. The problem is that a solid iron cone of height 48 centimeter and radius 12 centimeter is melted and recast in the form of a sphere. The question is, what is the radius of the sphere? So there are two concepts involved in it. When I was talking about volumes, I had explained that you can consider the volume if it is a solid object, then you can consider the volume as the volume of the material used in forming that object. And also I had talked about that you can consider volume in terms of the container which can hold what amount of liquid. This is a situation where it is the material consumed in forming that cone. Okay. So the same cone now is heated and melted, and after that the material which obtained after melting, that has been recasted into the sphere. So common feeling would be that whatever volume of the material which has been used in forming the cone, the same material gets melted, same volume of the material, and it is recasted into the form of a sphere. Therefore, the volume of the cone will become equal to the volume of the sphere which is recasted after melting the cone. What is the volume of, if suppose this is the cone and the cone has a height of 48 centimeter and radius of 12 centimeter, then the volume of the cone will be equal to 1/3 of pi r square into h, and this will be equal to 1/3 of pi into radius is 12, so 12 into 12, and height is 48. So this much of centimeter cube will be the volume of the cone. Now the same cone is melted and recasted in the form of sphere. So if this is the sphere and this is the radius of the sphere, we have to find out what is the value of this radius. Just for distinction, I am putting it r dash. So that volume of sphere is, radius of the sphere is r dash. Then the volume of the sphere will be equal to the volume of the cone, because the same material is being used. So this will be equal to the volume of the cone. Now we know that the volume of the sphere is written as 4/3 pi r, in this case r dash cube, divided, and that will be equal to the volume of the cone, which is 1/3 of pi into 12 into 12 into 48. Now this 3 and this 3 goes, and this pi and this pi goes, and then 4 3s are. So we can write r dash cube is equal to 3 into 12 into 48, which will be equal to, let's split it. So it is 3 into 3 into 4, into 48, and that 48 also we can split in terms of prime factors, which is 24, 12, 6, 2, and 3. So then this will be in the order of 2 into 2 into 2 into 2 into 3. Okay. Yes. So, and then we can do the pairing. So the pairing would be the 3 into 3 into 3, all 3 taken together, and then this 4 can be converted into 2, and remaining 2's can be converted as 2 into 2 into 2, and one more 2. And then you can take the pairing like this. So this becomes, so why I did this? Because here it is r dash cube. So I have to find the square, rather cube root of this number. So r dash will be equal to cube root of this entire number, whatever number it comes. And then because I'm taking the cube root, so I'll take 1 out of each pair of 3. This is 3 into 2 into 2, which is equal to 12 centimeter. So the radius of this sphere will be 12 centimeter. Okay. So with this example, you might have clearly understood that how to utilize the concept of volumes, which we learned in the last chapter. We'll take maybe one more problem which explains the combinations. There might be certain amount of material involved. At the same time, there are certain amount of volume of liquid which can be contained. So we'll take up that kind of example in the next video. Thank you.